xi, let xi have IID Bernoulli distribution I equal to 1 to etc. and Sn equal to x1 plus x2 plus up to plus xn, S capital N equal to x1 plus x2 plus up to plus xn, with n as a Poisson random variable with parameter a. Find one probability density function of Sn, second one is mean and variance of Sn, and the third part is probability density function of S capital N, fourth part is mean and variance of Sn. So this one is also application of probability generating function of Sn. Let P of S be the probability generating function of Xi, G of S be the probability generating function of N, and H of S be the probability generating function of S capital N. Then probability generating function of Sn theorem, H of S equal to G into P of S. So here first two part to prove n of one random variable, let Xi be IID Bernoulli random variables. IID distribution is probability of Xi equal to 1 equal to P, probability of Xi equal to 0, 1 minus P equal to Q. So these two are distribution part. First part, P of S equal to probability generating function of Si by summation of this term equal to summation of k equal to 0 to infinity pk s power k, where this pk is distribution pk equal to probability of x equal to k. We substitute, but here k is only 0 and 1, therefore probability of here k equal to 0 comma 1, therefore p of xi equal to 0 and s power 0. Then you put k, the summation is plus, you put k equal to 1, therefore probability of xi equal to 1 s power 1, therefore p of xi equal to 0 s power 0, therefore p of xi equal to 0 is q plus s power 0 is by 0 index 1, probability of xi equal to 1, this one is p, this one is ps, therefore p of s equal to q plus p of s. But our question is probability generating function of Sn equal to probability generating function of x1 plus x2 plus up to plus xn. This one is sum can be transferred to product by theorem. Probability generating function of x1 into probability generating function of x2 equal to probability generating function of xn. So here probability generating function of xi I equal to 1 to n, therefore here probability generating function of x1 is also q plus ps, probability generating function of x2 is also ps, probability generating function of xn is also ps, so this product is ps power 1. So equation number 3 says, 3 said that ps equal to q plus ps, therefore q plus ps power n. So this one is function of n, so probability generating function of Sn equal to, we take this function as qs equal to q plus ps power n. Then so probability generating function of Sn equal to q plus ps power n. So first part our probability generating function of s small n. So to find mean of Sn equal to expectation of Sn equal to q dash of 1. So equation number 4, q of s equal to q plus ps power n. So to find q dash of s, differentiating with respect to s, so x power n differentiation is n into x power n minus 1. So after that rearranging the term, qs equal to np into q plus ps power n minus 1. So this one is equation number 5. Variance formula needs q double dash of s. That's why here again differentiating with respect to s, q double dash of s. Here np is constant. Here x power n differentiation is n into x minus 1. Therefore n into n minus 1 p into q plus ps power n minus 2. Then that function of that parenthesis part differentiation is q is constant, that s is 1, therefore p. So therefore q double dash of s equal to n into n minus 1 p square, q plus ps power n minus 2. This one is equation number 6. From 5, from you find q dash of 1, just s is replaced by 1. Therefore this term as q plus b. So this one is p plus q equal to 1. Therefore np 1 power n, q dash of 1 equal to np. This one is mean of Sn. Then q double dash of 1, you substitute s in the place of 1. Therefore this one is s in the place of 1, n into n minus 1 p square 1 power n minus 2, n into n minus 1 p square of n. Therefore mean of Sn equal to q dash of 1 equal to np, and variance of Sn equal to the same formula, q double dash of 1 plus q dash of 1 minus q dash of 1 whole square. Therefore q double dash of 1 answer is in equation number 8, n into n minus 1 p squared, the square root of 1 equal to np, the square root of 1 equal to np whole square, and simplifying we get np into 1 minus p. Therefore 1 minus p equal to npq. Therefore mean of Sn equal to np, variance of Sn equal to npq. So the mean of the binomial distribution is np, variance of the binomial distribution is npq. Therefore this it satisfies binomial property. Therefore Sn has binomial distribution with the parameter n and p. Next to prove 3 and 4 here capital N, probability density function of capital N, that is Sn. So Sn means we need two random variables. So that our problem part given n is a Poisson random variable with mean A. Therefore probability density function of Sn n equal to g of s. Probability density function of Poisson random variable is e power lambda into s minus 1. Here parameter A e power a into s minus 1. So here probability density function of Sn equal to h of s by probability generating function Sn theorem g of p of s. What is p of s? Already using 3. P of s equal to q into p of s. Then using equation number 11. So here s, here you write s. Here s position is q plus ps. Wherever we seen s, that s in the place of, you substitute q plus ps minus 1. So p plus q equal to 1, that is 1 minus p. Therefore simplifying this, ps minus 1 equal to e power ap into s minus 1. Here ap is constant, that constant is stored to lambda. Therefore e power lambda into s minus 1. Therefore h of s equal to e power lambda into s minus 1. Here differentiating with respect to s, h dash of s equal to e power lambda into s minus 1. Here in power part lambda is constant, that is lambda. H double dash of s equal to lambda into e power lambda minus 1 into, again this power is differentiation is lambda. Therefore h double dash of s equal to lambda squared e power lambda into s minus 1. So this from to find equation 13 and 14 from you find h dash of 1 and h double dash of 1. H dash of means you substitute s in the place of 1 in equation number 13. E power 1 minus 1, that e power is 0. By 0 index we get lambda. Therefore h dash of 1 equal to lambda. What is lambda? Already taken, equal to lambda equal to ab. So from 14 h double dash of 1 equal to lambda squared into e power lambda into s minus 1. Therefore lambda squared into e power 0 equal to lambda squared. So here we found h dash of 1 and h double dash of 1. Variance of Sn here equal to h double dash of 1 plus h dash of 1 minus h dash of 1 whole squared. H double dash of 1 is also lambda, h dash of 1 is also lambda. Therefore lambda squared plus lambda minus lambda squared, this term cancelling, lambda squared equal to lambda equal to ab. Therefore from 15 and 17, 15 h dash of 1, mean of Sn equal to h dash of 1 equal to ab, and variation of Sn equal to ab. But actually h of s is probability density function of the Poisson random variable. Here also that mean and variance are equal. Therefore Sn is a Poisson distribution with mean lambda, that lambda is ap. So up to this, so we have seen the probability generating function of Sn and its application. So therefore this part is over. Okay, we will meet on next video.